Hello and welcome to another one of Moore's Chemistry Revision videos. Today we've got the mighty Mr. Lycett with us all the way from Science 12, and he's going to help us do some balancing equation calculations. And this one today we're going to use the blast furnace equation, which is a famous equation in chemistry. And the reason why we're picking this one, it's a little bit more difficult than the others, okay, than in the previous videos. Just like the previous videos, we're going to be using the same technique, okay? So the reason why equations need to be balanced is because of the first law of thermodynamics. Energy and matter can't be created or destroyed, it merely changes from one form to another. So what does that mean in English? In English it means that what we have to start with, i.e. on the left hand side, we must have the same amount of matter on the right. So, just like in the other videos, the first thing we're going to do is make a list of how many of each type of atom we've got in the equation. So if we look here, if we start off with the iron, we can see we've got 2 iron atoms because there's a little 2 here. So if we write that down, 2 times Fe. If we look, we've got 3 oxygen atoms in the iron oxide, but we've also got another oxygen atom in the carbon monoxide. So 3 plus 1 equals 4. We've got 4 times oxygen, and we also have 1 carbon atom in the carbon monoxide. And I'm going to hand over to Mr. Lycett, who's going to sort out the others.
Okay, so on this side of the equation, iron atoms, again, we've only got one of them because there's no number after it, so that just means that there's one of those. So 1 times Fe. Oxygen has a little 2 after it, so that means we've got 2 of those. And carbon, no number after it, so that means there's just 1 of those for carbon. Okay, do you want me to balance this side now?
Yeah, you can say, yeah.
So, in terms of numbers, the right-hand side and the left-hand side aren't matching, and they need to at the end. That's the objective of balancing equations. So, as you can see, in terms of ions, there's just a simple doubling needs to take place there to get these to equal. So we can't change the little numbers, we can't put a little number after it, but we can put a big 2 in front of the iron, and that means we have 2 of those when we update our list. But our oxygens also don't balance. Now, we have 2 of these on my side and 4 on Mr. Moore's side, so again, I can just simply double the number of oxygens to make those equal, sorry. But as you can see, oxygens aren't isolated on their own, they've got a carbon atom attached to them. So if I double the number of oxygen, that being the only way I can do so, can't change the numbers, I also have to double the number of carbons. So if I change my list here, 2 times 2 oxygens means I've got 4 of those, and 2 times 1 carbon means I have 2 of those. So we now have another problem that Mr. Moore is going to address on this side.
Okay, so if we look, we've got 2 iron and we've got 2 carbon and we've only got 1 carbon here, okay? So as Mr. Lycett said, we can't change little numbers, I can't put a little 2 there, okay? So if we want to increase the number of carbon atoms, I need to put a big 2 here, okay? And if I update my list now, I've now got 2 carbon atoms, so I'll change that to 2, and that also affects the number of oxygens, okay? So because it's at the front of the molecule, so 2 times 1 is 2, so we've got 2 oxygen atoms there, plus 3 oxygen atoms here, makes a total of 5 oxygens.
Okay, so our carbons equal now, however our oxygens don't. And the only oxygens on my side of the equation are in the CO2 molecule. And with balancing equations, the rule of thumb, if you like, is you try the next highest number with respect to these large numbers at the front. So I'm going to change that 2 to 3 and update my list. So 3 times 1 carbon takes us to 3 carbons on this side, and 3 times 2 oxygens takes us to 6 oxygens on this side. Now I'm going to see if we can update Sarah's side.
Yeah, so the only thing we've got to do now, if we want to look at the number of carbons again here, we've got 2 carbon atoms here, okay, where we've got 3 on the other side, and we've got 5 oxygen atoms on the left hand side, but we've got 6 on the right. Now this next fix will actually fix both of these in one step, okay? As Sarah said, we've tried 2 there. The next obvious number to pick is a 3. So if we try putting a 3 there, and again, numbers at the front of molecules affect the whole molecule, so that now means we've got 3 carbon atoms. So if we update our list, that goes to a 3. And it also means we've got 3 oxygen atoms here, because remember it covers every atom in the molecule. So we've got 3 oxygens there, plus another 3 there, makes 6. So if we update this list, and you can now see we've successfully balanced that equation. Hope you found this video useful. Thank you.